So, again, ladies and gentlemen, in chemistry, we are only as precise as the tools we use. We are going to find out today that 54 meters does not equal the same as 54.000 meters. Why do you think 54 meters is not the same as 54.000 meters? What's a big difference that you see in them? What do you notice between the two? Dulce, what do you notice between the two numbers? Which one's longer? That one. These zeros means that my answer, I need to get that little sheet over here, is precise all the way out to the thousandth place of a decimal. So we have this little sheet of paper here. There's a goal to help you out. We see that 54 stops at the ones place. So when we get into rounding stuff, this 54 can be anywhere between 53.1 to 53.9. That's a pretty big range of numbers. If we're rounding things. Sorry, 54.1 to 54.9. It's a pretty big range. But if I'm saying that I'm up to 54.000, my precision is much, much smaller. Up to a thousandth place, I could say that this number is exactly 54. This 54 over here, I have a huge range of what it can be. The term that we're going to use is magnitude for this. Now, it may not be a term that makes a lot of sense to you now, but will be one that we're going to try to instill in the future. The reason why this number is more precise than this one is because this number has many more significant figures. Significant figures are digits. Remember, guys, if I'm writing something, you definitely want to be writing it because you're definitely going to see it on a quiz or a test. In a measurement, so I'll make sure in a measurement that contributes to the number's precision. We're going to see the more significant figures, or short for Sig Figs, the more precise the number. The more sig figs a number has, the more precise that number is going to be. Now you might be asking yourself, well, Mr. Wassman, how do I count sig figs? Are there like rules to this stuff? I'm so glad that you asked, because there are rules to sig figs. And which numbers? Do we need that back for a second, guys? I apologize. I'll leave it for another 30 seconds and we'll move on with it. But like anything in chemistry, there's rules to it. Not every number has the same amount of sig figs, but I need to know the rules for counting a number sig figs. And we break it down pretty easy. There are four major things when we're counting our sig figs. To help us out with counting our sig figs, I want to look at, if you have your classwork / homework, I want to look at letter I. 0.0230 centimeters. Now, to help us with this process, what we're going to do is we're going to go through a step, and then we're going to circle all the numbers that are associated with that step. So my first rule when counting my sig figs is I need to circle every non-zero number in the number. Non-zeros are always significant. So if non-zeros are always significant, what numbers am I going to circle in my 0.0230 centimeters? What two numbers am I going to circle? Just shout them out, guys. It's okay. Travis, hit me up with a non-zero number. 3? Jerome, give me the other one. No, on my question. 0.0230. What's my other non-zero number up there? You don't know what the non-zero number is? Abby, help our man's out. What's the other non-zero number up here? 2. So what I'm going to do is I'm going to circle these numbers. Perfect. Oh, darn it. I was one for step 2. Well, oh well. Actually, I'm going to extend this number out. 70 cm. There we go. Now we have it. Number 2, I need to circle. So keep in mind, guys, I extended the number out a little bit to make sure we had room for step 2. I added a 70 to the end of my I. I need to circle each trapped 0. Now, trapped 0 just means it is a 0 between any non-zero. For this one is also always significant. So if I go back to my example here, 0.023070, which 0 is trapped between two non-zeros? This 01, 02, or 03? 02 is trapped between two non-zeros. That means it's always going to be significant. Does that make sense? Yeah, I'll go back down a second. Slide down. Rules 1 and 2 are very straightforward. If I have this, it's always significant. Rule 3 only comes in play when we see a decimal. Rule 3. Circle. Excuse me. Each trailing zero. There's a big one. Only if there is a decimal. No decimal equals not significant. I ran out of space. So I go back up here. I'll give you a second, guys. I apologize. I get on a roll, and I'm like, oh, we're going to get this done. Well, I'm sorry you're tired, my friend. So if I go back up here, I have one tailing zero. Is there a decimal place present? Do I see a decimal place? That's right there, right? So that means that this zero has to be significant. So where 1 and 2 were always significant, 3 is sometimes significant. Step 4 is my never significant. Number 4. Leading zeros, i.e. zeros in front of a number are never significant. These numbers are called placeholders. Placeholder numbers are never significant. And we're going to go over what placeholder numbers are. So, if I go back up to the top to my question, these two zeros, 0.0 before my non-zeros, never count. So if I asked you how many significant digits how many Sig Figs are in 0.023070 cm. We just redo what we did. We had circled our 2, we circled our 3, we circled the 7, we circled the trap 0 between the 3 and the 7, we circled the last 0 because of the decimal place, and we X these guys out. 1, 2, 3, 4, 5. It has 5 Sig Figs. And that's how we're going to count these things. We are going to learn that the placeholder zeros, which are our leading zeros, and trailing zeros with no decimal. Are never significant. Let's do a couple that are not on your homework. So we're just going to pick. We're going to pick like 2, 3. Then we'll pick 2 from the homework to kind of walk through. So if I had a number that was 74 meters, how many Sig Figs is that? $74 meters. Show me by fingers. Is it 1 Sig Fig, 2 Sig Fig, 3 Sig Fig, 4 Sig Fig, 5 Sig Figs? If we need a second hand, we'll use the other hand. How many Sig Figs do you see in front of you? All right, an option for 2. What was that, Greg? All right, nice. Thank you, Greg. Abby, what do you think? Just show me a finger. How many fingers do you think Sig Figs I have here for 74? Perfect. Perfect. It is 2, right? If I circle them, I go through my rules, right? My first rule tells me, excuse me, that I need to circle all non-zero numbers. 7's a non-zero number. 4's a non-zero number. 1, 2. 2 Sig Figs. What if I have 740 meters? How many Sig Figs do I have? Walk your way through your steps. I recommend writing the question down. Show fingers. I want you to raise them up so I can see them. Is it 2? Is it 3? Which one is it? 2 or 3? Got some 2, 2, 2, 2. Got 1, 2, 3. Got 2, 2. All right, let's go through our steps. Step 1. Step 1 tells me to circle all my non-zero numbers, right? All right, so I circle my 7. I circle my 4. Step 2, I'm going to look for any of my trapped zeros. No, it's not trapped, it's by itself. So I don't have anything for 2. 3, circle each trailing zero, so the zeros that come at the end of my number, only if you see a decimal. Do we see a decimal? No. So that means that this is the placeholder. So we only have 2 Sig Figs here. Do we understand that one? Let's try 0.740 meters. Jerome, make sure you're writing this down, okay? How many Sig Figs do we count now? 1 Sig Fig, 2 Sig Figs, 3 Sig Figs, or 4 Sig Figs? Go through your steps. Show of fingers, gang. What do you think? That's 3. That's a 3. That's a 3. What do you think, Greg? Shoot me fingers. All right. Abby, what do you think? All right. Keely, what do you think in the back there? All right. So, let's count them down, right? Going through our steps. Ciao. Got my steps right here with me all the time. Step 1, circle all my non-zero numbers. 1, 2. Step 2, circling my trap zeros that are in between non-zeros. I don't see that. 3, circle each trailing zero only if we see a decimal. Do we see a decimal? Absolutely. So that counts as another one. My last step, leading zeros are never significant. These are numbers that come before any non-zero numbers. I have 1. Therefore, I have 1, 2, 3 Sig Figs. Let's do a couple on the homework. So remember, we are looking at questions 5 all the way down to 13. So I'm looking at question 1 here. Put that there, kind of like keep the bleeding from it going all the way through. We'll look at A. Determine the number of significant figures in each of the following. I want to look at A. I want to look at B. I want to look at D. So how we're going to do this, gang, is that we're going to circle these numbers. So we got our rules here. Rule 1 tells me circle all non-zero numbers. All right. The 6 is a non-zero number. Is the 5 a non-zero? Yep. Is the 7 a non-zero? Is the 1 a non-zero? How many significant figures did this one have? 4. For B, you tell me, how many significant figures do you count? 3. We go through our steps. Step 1, we circle our non-zero numbers. 1's non-zero, right? Is 1 a non-zero number? Yeah, 1's a non-zero number. Is 5 a non-zero number? Yep. Is 7 a non-zero number? Yep. All right, so I go to my next step. Step 2 is I look for any of these trap zeros. I don't see any trap zeros between two non-zero numbers. Step 3, circle any trailing zeros. If we see a decimal, we see a decimal, but there's no numbers in the back, right? Step 4, leading zeros never count. I have 1 leading zero. I'm going to cross that off. That leaves me with 3 significant figures. I want you to do D, and what I want you to do on your whiteboard, you're gonna write down how many significant figures you count. 1, 2, 3, or 4. Chance to see what you got. I can bring you. So trailing zeros are just anything that's in the back of the number. Not just one of the correct. So on your whiteboard, I want you to write down how many significant figures you think you count there. 1, 2, 3, or 4 that you find in 2,500 or 2,500. Everybody got an answer? All right, let's see what you got in 3, 2, 1. Let's see them, gang. Perfect. All right. Looking good. Very tough. What do you got, Kiki? Yeah, that's all right. You said right how many Sig Figs you counted. But, ladies and gentlemen, it is How many was it? 2. So I go through my rules. First thing I do is I start off with my non-zero numbers, right? Step 1. Non-zero numbers. 2's non-zero. 5's non-zero. Step 2, I have no trap zeros. Man. Don't have to worry about that. Trailing zeros only count if there's a decimal. Do we see a decimal present? No. So these 2 don't count. That leaves me with 2. Let's do one more. Let's do L. On your whiteboard, I'd like you to write down how many sig figs that you count. Is there 1, 2, 3, 4, 5, or 6 sig figs for L? Just write down your whiteboard. Today we are counting. Today we're going to be rounding in a second. I'm going to show you exactly what you got to do to round. Does everybody have a number on their whiteboard? All right, gang, let's see what you guys got. In 3, 2, 1. Let's see them. Look at that. All right, all right. Some numbers there, some numbers. Nice work, nice work, nice work. All right, let's come to the answer together. All right, so first thing I gotta do is I gotta circle all my non-zero numbers, right? First non-zero number is my 1, my 2, my 9. We agree that those are non-zero numbers, yes? Perfect. Step 2, I have to circle any trap zeros that are caught between 2 non-zeros. Do I have a trap zero in this question? I do. It's right here. Between the 9 and the 7. Unfortunately, my Sharpie's too big. I've already covered up the numbers. Do I have any tailing zeros? I do. Do I see a decimal place? Do I count it? Yes. Leading zeros. Do I have one? Are they significant? Perfect. So that's 1, 2, 3, 4, 5 sig figs we got for that one. Does that make a little more sense? All right. A little bit of time we got left. I want to look at rounding. So you're going to do a lot of rounding here. Now, when we are rounding to a certain amount of sig figs, sometimes it's easier to write the number out. So if I want to round to 4 sig figs, so I got 7, 4, 2, 3, 9, 6. So I write my number out, and then the first thing I want to do is I want to circle all of my significant figures. Is the 7 significant? Yep. Is the 4 significant? Is the 2 significant? Is the 3 significant? Is the 9 significant? Yes. Yes. Is the 6 significant? So all my numbers are significant. So when I say, hey, I want you to round to 4 sig figs, you're going to count them out from the left to the right. 1 sig fig, 2 sig fig, 3 sig fig, 4 sig fig. I'm then going to draw a rounding line. Question to you. If I'm rounding between 3 and 9, is the 9 big enough to push my 3 to a 4? Do the other 3 numbers get changed? No. 2, 4, 7. Now here's the thing. Is that right now, my number ends in the 100,000th place. I need my rounded answer to stay in the 100,000th place. What can I put on the other side of my rounding line to keep that 7 in the same place? A 0. Does that make that 0 significant or insignificant? Insignificant. Why? What am I missing? I'm missing a decimal place. Boom, boom. So my first one, 7, 4, 2, 4, 0, 0. Whenever we round something, we want to make sure that if my number started in a certain place, it needs to end. It needs to also end in that same place when I round. If I owed you $742,000 and I only gave you back $7,400, you'd be rightfully upset with me, yes? If I owed you, if I owed you 7,000. If I owed you $742,400 and I only gave you back 7,424, you're losing a lot of money. So how I make sure you get the same amount of money is I put those zeros as placeholders. Because it keeps this 7 in the 100,000 spot. It keeps this 4 in the 10,000 spot. It keeps this 2 in the 1,000 spot. It keeps this 4 in the 100 spot. When we round, it doesn't mean the number gets shorter. It just means I'm writing a bunch of zeros. Let's do 6B. 6B, I'm going to 3 Sig Figs. Where am I going to put my rounding bar? If I want 3 Sig Figs.
Next to the 2.
Next to the 2. 1, 2, 3. So the 7 stays the same. The 4 stays the same. Is the 3 big enough to push the 2 to a 3?
No.
Nope. So what do I put in the place of the 396?
0.
Zeros. 1, 2, 3. You try to see by yourself. And then we're going to look at 7 together. Now I want you to write C on your whiteboard. Once you found out your answer, I want you to write C on your whiteboard. You're going to show me what you got. Make sure that you're writing those right answers also on your homework. So that's why you got them both places. All right. Does everyone have an answer on their whiteboard? See everybody somewhere on the whiteboard? Let's see what you got. In 3, 2, 1. Let me see what you got. Absolutely. Absolutely. Great visual whiteboard. Yes, right on the whiteboard. Nice. Nice. Absolutely, guys. Absolutely. Seven, 4, 2, 3, 9, 6. Count them over. 1 sig fig, 2 sig fig. Rounding bar. Is my 2 big enough to push my 4 to a 0? Absolutely not. Will I put in spaces of the 2 to 3 to 9 to 6? Zeros. 4, 1, 2, 3, 4. All right, so let's talk decimals. So number 7, I'm going to put another piece of paper right here because it's easier this way. I have 0.07284. That's the number I'm working with. I need to round to the 4, the 3, and the 2 sig fig. So first thing I need to do is I need to count out my sig figs for 0.07284. How many sig figs do you count, guys? Show me a thing of fingers. All right, got an option for 5, got an option for 4. What do we think? Let's count them together. So my rules first, circle all my non-zeros. I know 7 is non-zero. I know 2 is a non-zero. 8 is a non-zero. 4 is a non-zero. We agree with that one, right? All right, step 2, trap zeros. No trap zeros I see, right? Skip 2. Go to 3. Trailing zeros. Zeros at the end of my number, but only if there's a decimal. I have a decimal. Do I have trailing zeros? No. So I can skip over 3. Leading zeros. Any zeros that come before non-zeros. Do I have them? Are they significant? Never. So I have 4 sig figs here. So if my first question asks me to round to 4 significant figures, digits, 1, 2, 3, 4. So 0.07284. Is there anything behind the 4 to push it to a 5? So that means that A is 0.078. Oh, so 284. I knew there was another digit in there. 3 sig figs. Rewrite my number, 0.07284. What 2 numbers am I putting my rounding bar in between? If I want 3 sig figs, I want to drop this rounding bar somewhere in my number, right? Between the 8 and the 4, right? 1, 2, 3. Is the 4 big enough to push my 8 to a 9? Nope. So 0.0728. And I think we need to go to 2 sig figs? Yes, 2 sig figs. 0.07284. Where do I drop my rounding bar at? Between the 2 and the 8. Absolutely. Is my 8 big enough to push my 2 to a 3? Absolutely. 0.073. The easiest way to solve for any of your rounding questions is to first figure out where are your sig figs. And sometimes it's easier. If we drop the bar, we can visibly see where I need to round, right? If you feel comfortable with rounding, you don't need the bar. You don't have to put the bar. If you want to show me where you rounded at, you can draw that line. It helps me because I'm a very visual person. If you're a very numbers person, you don't need it. I'm not taking points away from you because you didn't put the line there. I'm just going to be counting your sig figs. So, no. You never, because remember, because if I put a 0, good question. Great question, honestly. If I put a 0, let's say I said round to 2 sig figs, right? And I did 0.073. If I put placeholders there, 0, 0, those zeros have now become significant. Why? Decimal. I only want 2 sig figs. I'm not going to put them there. If I have a large number, I have placeholders behind my number. If I have very small number, I don't use the placeholders behind my number. Does that make sense? Why we don't do it? Perfect. So we got 10 minutes, gang, to the bell rings. So, I'm going to give you this time. You can work on your packet. If you got any questions for me, you let me know. In 5 minutes, I'm going to have you guys start trailing, putting stuff away, grabbing your phones, grabbing your seats. Sound good? Dope.